Great, thank you. Got it. Okay, good evening, everyone, and welcome to our Vancouver DevOps Meetup. My name is Andrzej Kamensky, and together with Willie, Ilse, and Shai, I am co-organizer of this meetup. So agility in general terms is really about the breaking silos. So pure agile was about the breaking silo between the business and IT, and DevOps was about breaking silos between development and operations. Now, security cannot be left out. So you're the concept of DevSecOps, but it's not only about improved collaboration or breaking silos. Our systems are becoming more and more complex, and with move to the cloud, if we don't keep the tech debt in check, this will result in a higher probability of being hacked. Now, did you know that over 93% of healthcare organizations have experienced data breach in some kind during last 5 years? And this is according to the Black Book research. The cost of fixing a security vulnerability in development stage is 100 times cheaper than fixing it in production. And according to a survey that was done by DevOps Institute, 63% of organizations that practice DevSecOps reported faster remediation of security vulnerabilities. How much faster? According to Forrester, identification is 5 times faster. And according to Synopsys, remediation is 3 times faster. So what do we need to do to manage the secrets and configurations in production systems? And what we really want to achieve from that is to reduce the risks, the costs. We want to increase the speed and agility of delivery. So we're going to find out about this today. So Shai, over to you to introduce our speakers.
Thank you so much, Andre, and thank you for kicking us off with that message. I'm super excited about the first session. Most people who have worked in our industry know that you actually always need to have a good friend in the security team. So if you don't have any good friends in the security team yet, I'm happy to present Mr. Matthew Chatter here, who's joining us from Calgary. Matthew is a cloud security architect with Palo Alto Networks, and he comes with us with all these juicy tidbits about how to make friends in DevSecOps. Without much further ado, over to you, Matthew.
Perfect. Yes, thank you very much for the introduction. Let me just get this queued up here. Start sharing my screen. Okay, there we go. All right, I assume you can see that?
Yep.
Fantastic. All right. Yeah, so good evening, everyone. Yeah, as the title suggests, we're going to have a little chat about cloud app security and DevSecOps and how you can deploy faster and more securely along the way with hopefully a little bit less pain. Sorry, we're on Google, so it's always a challenge to get going. All right. So first, I wanted to introduce myself, right? So as Shay mentioned, I'm Matthew. I work for Palo Alto Networks. I work here exclusively across Western Canada, even though I'm based in Calgary. I'm often out in Vancouver. I've been in IT for about 20 years now in various capacities. And really, I believe that cybersecurity should be an accessible topic for everyone. I try to keep it an approachable topic. And I'm not out there reading the compliance standards, but if you're into that kind of thing, go for it, right? So in my current role, I get to live action role play as a DevSecOps engineer, which I really enjoy. I get to play with all the fun toys, but at the end of the day, they don't let me near production systems. But really, I get to chat with all types of DevOps and security folks from organizations of all shapes and sizes, and then pass that experience on to you fine folks. So I'm not a developer by trade, but I've messed with enough C# and C and Python to know which one I prefer. All right, so for the next 25 minutes, we're going to cover a few things. So we're going to start off with why is modern application security so challenging? Then we're going to change gears and talk about shifting left and how we can address some of those challenges in a new way. And then really, I wanted to leave you all with some practical advice, right? So I like to expose people to open source tools and show them things they can start doing today, tomorrow, to be more secure. And then we're going to wind up with some goats that we're going to clone. So that's always a fun activity. And of course, shameless plug, right? So I do work for Palo Alto Networks. We do have a cloud native application protection platform called Prisma Cloud. I'll make references to it a few times throughout the presentation as a tool that you can adopt. But really, if you ever want to chat with us offline, we're available, right? We love this stuff. Just reach out. Okay, so let's start by understanding really why modern app security is so challenging and why the shift left movement is so important for DevOps practitioners in all organizations. So as we go through this, think about your own experiences with security. And really, if you're with a small organization or a bigger organization, you're going to experience these differently. If you're lucky, not at all, not yet. But really, all organizations are going through this transformation and they're going to manifest themselves one way or another. So here we have a pretty familiar analogy, I'm sure, for most, right? Organizations which have been around for a while tend to have teams of people who approach cybersecurity like they're building castles. Applications are hosted in data centers and they're using methodologies like zero trust, and they're layering security around the crown jewels. And they'll have lots of firewalls at multiple levels to inspect and carefully enforce the traffic that's allowed in from the outside. And maybe you're using VPN clients and virtual desktops for your remote users. And this meant that you really needed to have a firm grasp on all the users and their identities and applications across the entire organization, as by default, nothing should be allowed to communicate with the rest of the network unless you explicitly tell it to do so. And then within these environments, nobody had God mode, right? Permissions were carefully delegated out to teams of network analysts and infrastructure analysts and so on. And this is a very effective security model, right? For organizations that are under heavy compliance standards. This is what you do, right? Breaches are quite rare if you do it well. There's lots of monitoring and prevention tools throughout, and malicious activity can usually be contained quite quickly. But these environments are not flexible, right? Deploying new apps took an immense amount of time and planning, in part because no one person had the knowledge or tools or automation or credentials to really do it all. And obviously, as DevOps practitioners, we know that that's all changed, right? If we're looking at cloud-first organizations or you're building modern apps, it looks a lot like this villa here, right? There's no well-defined perimeter to build a firewall around. You could be spanning several cloud providers and regions at the same time, and it's always expanding and contracting to meet demand. Additionally, right, the various IaaS, PaaS, and SaaS apps, which make up the foundation of your app, can change very quickly. As the needs change, developers like to bring in new tools. And the permissions to operate them all, they vary radically. And then lastly, right, your developers and their CI tools carry a high level of privilege, right? They need the ability to deploy, modify, and destroy most running deployments as needed. So depending on the size of your org, you may not even have dedicated security people if you're leaning to the right and you're very cloud first, right? You could just be following the well-architected frameworks and patching the vulnerabilities that you know about. And really, there's a lot of implicit trust here between and amongst yourselves and the resources that you deploy. So really, if you're working on either end of this curve, things are usually pretty good, right? You've got a firm grip on things from decades of experience, or you're too new to really have that substantial technical debt. And the overwhelming majority of organizations are caught somewhere in the middle, right? They're in this transition zone. And these organizations are going through this period of flux, right? Maybe as they're launching new lines of business or they're overhauling their applications and bootstrapping their very first own in-house DevOps practices. And they're deploying more workloads to the cloud, right? Sometimes they build it themselves. Other times they bring us in as a third party to build it for them. And the security teams here are suddenly responsible for managing castles and villas at the same time. And since castles are what they know best, they try to bring all that forward and they create a lot of friction while they do it. And they discover that the old security paradigms don't really work here, right? The moment you try to build walls around and in between your modern apps, the more you risk ending up with something like this, right? It's a very complex and unstable disaster waiting to happen. And this is that unnecessary growing pain I was referring to earlier. So if you are a DevOps practitioner caught up in a world like this, you're probably having a miserable time, right? Here are some of the telltale symptoms if you're unsure, right? It's like you might have access to no live systems, maybe even read-only you don't have, and you're requesting access to them every time you need to do something specific, or your minor changes are being reviewed weeks in advance and often questioned by people that you maybe haven't met before. Or people are trying to assign ServiceNow tickets to you and ask you to remediate issues that you didn't even know existed. Or maybe there's a recurring meeting in your calendar asking you to discuss a firewall integration project, right? Whatever that's about. So from what we've seen, DevOps teams caught in these types of scenarios will usually just splinter off and form their own little working group to get out of the swamp. And that's usually once the business figures out that they're not delivering fast enough and security is really just slowing them down. So really the security teams hate it just as much as the DevOps teams at that point, right? It's very painful for them. So we talk to a lot of them because usually the security teams that we know are the ones that are going along for that modernization ride with their organizations. And when we talk to them, right, they all say the same thing. They say that the tools they bought, trained on and integrated, they don't work anymore. And most can't even detect the types of cloud native threats that they're worried about. The cloud providers all have tools, but they're all very different and they only solve one problem at a time. And they usually have weird billing models like per query, per gig, per minute, whatever it is. So then they have to go out and buy brand new tools and then integrate them. And then by the time they do that, they feel outdated, right? They're just generating lots of noise and everything's on fire all the time. So then because of that, they're afraid to touch the live systems because the tools can't really give them the full application context of what it is they're trying to secure. And they don't want to be the ones to touch a live system and make that disruption. So then at that point, most security teams agree if they can't touch the systems, they can at least try to determine policies and maybe they can block new risky behaviors. But the developers and DevOps teams, they just have to jump over them, right? If the policies are too heavy-handed and the developers don't want to log into the security tools, right? They really don't, right? You guys don't want to log into the latest security tool from whoever, even Palo Alto Networks, if you can avoid it, to see what's going on, because again, right, you have a job to do and security might not be a part of that. So then they'll say, okay, right, we have pre-existing vulnerability scanners and we're going to scan everything. We're going to scan the code repositories. We're going to scan the container registries. We're going to scan the live hosts. We're going to scan the serverless functions, but they just surface all that noise and no one really knows, right? You have a registry with 1,000 containers in it. Which of them actually matter, right? It becomes a bit of a futile effort to go and remediate them. So then lastly, right, the most difficult part of that is that they feel like they can't measure their own success anymore, right? They don't know how to measure it, right? There's always more vulnerabilities as more apps are being built and policies are just being jumped over and they can't really knock down anything that is measurable to them. So that just makes all this frustration, right? And we call it the stalemate in the status quo, and it happens in a lot of organizations. The security teams, right, they've collected their army of new security tools, each with their own 4-letter acronyms. They give them some hints as to the posture of the cloud, but they're not application developers, right? They don't really know unless they spend the time. So then they attempt to shoehorn them in, right, to the rest of the development process, and it's met with questionable effectiveness, right? Security testing just hasn't made it into the full development process to the extent that it needs to. And then this is the point where, right, we need to change the conversation, right? And this is where we talk about shifting left. So we need to break the stalemate and reduce the volume of alerts and reduce the pain by 10x or 100x, right? Because like we started this meeting out with today, it's way easier to fix it and way cheaper to fix it when you're building it than once you've gone live. So that's a bit of a history lesson, right? That's how we got to where we are now. And this is the point where we should shift gears and talk a little bit about the types of approaches that you need for modern applications. And I like to start this section with a statement that will likely not surprise anyone here, right? Modern apps are more assembled than built, with open source libraries and packages accounting for over 70% of the code base. This is a great statistic for those of us on the security side of the house, because it means that we don't need to worry about every single line of code or method or function within your code base anymore. We can just audit all the open source packages out there instead for all of our customers, and then spend our focus on the remaining 30% as we need to. With all that being said though, right, applications can still be assembled in ways that create something radically insecure. So how does that happen, right? Now, sticking just to the development side, right? We'll get to operations in a minute. So if you're a developer, right, you didn't wake up and say to yourself, I'm going to make an insecure application today, but it does happen, right? So maybe you have a tool like a SAST or a DAST to do that static or dynamic analysis of your code. But really, there's other things that are often beyond your control that will lead to something insecure. Time pressure, right? It's massive, right? Our customers are pretty upfront that without public resources like Stack Overflow, nothing would ever get done on time, right? Everyone jokes about it, but everyone knows it's true. And unfortunately, right, the most brief and concise answers that you get from those forums, they have no concessions to security, right? So totally not picking on Stack Overflow, because the same is true of really any documentation site or GitHub Autopilot and now ChatGPT, right? It can give you working code. It's guaranteed to not be secure code, but when do you have those security reviews, right? If you're under a time crunch, you could already be several releases ahead before that happens. Platform updates, right? There's a reason you can still deploy Node 10 applications on Azure Web Services, despite it being end of life for like 2 years now. Keeping the core components of your app up to date is really hard to begin with, especially if you have to keep it as is and on life support for a very specific customer. Rapid development cycles, right? It moves fast. And even if you do have a security team that's on the ball, they could be several releases behind when they propose a fix. And then no one wants to be responsible for pulling that forward to the main branch and validating that none of the other carefully implemented features have been broken along the way. So they just get stuck in this loop where they're constantly trying to fix the issues and never getting it deployed. Changes to the underlying stack, right? Everyone is going on this journey of runtime modernization and optimization. But every time the runtime environment changes, it brings unique challenges, right? Your security considerations, if you're building a Java app on a host, very different than if you're deploying a Java app to Lambda. Then lastly, our upstream dependencies. And this is a big one, right? Like your application has thousands of them, right? And you aren't responsible for maintaining any of them, right? Only patching them wherever you can. So every 3 to 6 months, a major vulnerability will come out in any given library, and it's going to throw your team into this panic to figure out your exposure and to mitigate it. All right, so we picked on the developers, right? Let's look at the other side of the coin, right? Let's look at ops here. You can have the most secure code base in the world, but you could find it compromised during deployment or at runtime. So if we pick on a few notable examples, right? Like CI/CD is a focus area for a number of reasons. So the recent Circle CI breach is a great example of how quickly things can go wrong. You can have secrets hard-coded or reused throughout the entire build and deployment process. You can have build tools that might be stuck running legacy integrations, or maybe the trusted base images have come outdated, right? They come from an outdated source, or they've been poisoned along the way, right? It does happen. Everyone's accustomed to pulling the latest container image from wherever, but the owner of the repo designates the latest tag, and it doesn't mean it's been tested or that it's necessarily secure. So despite our best intentions, the bad stuff does tend to sneak its way in. And this is such a huge issue, right? That even Microsoft couldn't divine the nature of what their customers were doing in the free tier. So people were abusing Azure DevOps and running crypto miners to their heart's content, right? This just reemphasizes to the need to really inspect things as they're running, because it's hard just to look at an image that's not been deployed yet to determine whether it's trustworthy. So now that we've deployed our stuff, right, we have the runtime environments, and they always fall under heavy scrutiny, right? This is where the exposed vulnerabilities get discovered and exploited. And the results of that exploit can vary widely when it does happen, right? Surprise crypto miners on your container hosts are a party favorite. Denial of service attacks, data exfiltration, or maybe even lateral movement thanks to resources that have been provisioned with overly permissive IAM roles. It's extremely difficult to follow the principles of least privilege with IAM. So even something as simple as tightening the screws on an S3 bucket or a DynamoDB can go a long way to reduce the blast radius of an attack, right? And not just for hosts, right? But your serverless functions are a prime target as well, right? A lot of people tend to think that because they're so short-lived, they aren't a target, but we found that their lightweight and unhardened nature usually makes them quite a bit weaker. Then adversaries also like to use them to scale, right? Once they find a way to pop one, they'll trigger scaling events and then go after the rest of them. And you don't want to be on the receiving end of the bill of, 5,000 lambdas that have been doing something for someone else, right? So all in all, right, you need to have a solid grasp of the fundamentals, right? You need to be scanning everything that the developers are doing for quality and vulnerabilities. You need to be managing things through the deployment process, but then you also need to keep an eye on the runtime environment. You need to actively defend your assets there. right? So clearly we can see, right, modern apps require that different approach to security than the traditional, castle methodology that most people are used to. So if your organization already has an established DevSecOps practice, amazing, right? For what we've seen, these roles are extremely rare, right? There might be one DevSecOps focused employee per 200 developers or DevOps practitioners. So for the rest of us, right, that means shifting left to help our friends in security unlearn the traditional things they've done and they've learned, and maybe to help them thrive in this new world. And that's essentially what shifting left is in our eyes, right? It's about sharing the burden and the responsibility of cloud and app security. And the rationale, again, right, extremely straightforward. It's easier, cheaper, better if you fix these issues, right? No different than engineering your car to prevent time-consuming recalls, right? So how do we do it? So really, this is the part where we get into some prescriptive advice, right? And regardless of what tools you use to do it, or when you get there, right, baby steps at a time, there's a few basic elements that we think everyone should follow, right? The first is that developers and DevOps should really never be expected to log into a security tool, right? Feedback needs to be given in the tools they use, like the IDE, the VCS, and the CI/CD tools. And then secondly, the time-consuming security tasks need to be automated, right? Vulnerability management is a good example, right? Getting a bump fix recommendation should be provided as early as possible with the least possible amount of effort to get around critical vulnerabilities. A lot of tools will just recommend the latest stable, which that's usually never possible, right? Policies which do block development activity should be discussed and implemented as code, right? Everything's as code now, and security policy as code is no different, right? So these tools should inform a developer or a DevOps person if they're about to commit something egregious, right? Like sending secrets up to a public GitHub repo, right? It's absolutely infuriating to go through the process of building this beautiful containerized application only to have the deployment blocked, right, when you go live, when that feedback could have been provided all the way at the start, right? From the very first line of code in your Docker file could have told you that this was never going to work, right? And then lastly, we need to stop the game of alert whack-a-mole, right? We need to respond only to what matters, not what we think is important or what the security team thinks is important in that moment. All right. So let's get to the fun part, right? Let's talk about some of the tools and things that are out there, right, that you can start playing with today to be more secure and get to that lovely state where your deployments are just flying and no one from security is trying to kick down your door. So this is a fun tip for everyone, right? And I'm probably preaching the converted since it's pretty common in DevOps practice now. But if you aren't already doing this to the maximum possible extent, right, challenge yourself to use infrastructure as code for every new deployment going forward. Right, it's way cooler than doing things by hand if you haven't done it. Right, there are domain-specific languages out there like CloudFormation and ARM and Bicep, but Terraform is the clear winner across the industry. Right, it's cloud agnostic. It can be used to automate absolutely everything. Right, not just infrastructure. So if you need to deploy it, there's probably a Terraform provider out there for that. So the benefits are obviously huge for DevOps. Right, you can automate everything, sometimes even from your existing Git and CI tools. Right, if you use something like Terraform Cloud, you can just kick off your provisioning job automatically via GitHub action once something gets committed to the master branch. And since Terraform is declarative, as are all IAC languages, right, it maintains this awareness of your existing deployments. And you can deploy just the changes that you need to your application to get things up and going. But for security teams, right, this is huge, right? It's basically pure magic for them, right? So this is a great example of something that you should be doing is already helping the security team, right? So now they can scan all of your IAC templates instead of needing to audit all of the live systems out there, right? This is a game changer, right? As it means that they can also anticipate issues before they happen by anticipating what those deployments are going to look like, right? So those permissions on that DynamoDB table that went live, they know before it went live if they were too open. And then furthermore, if someone changes that, right, at runtime, they know that there's a deviation from the standard and they know exactly where to spend their time, but we'll touch on that in just a moment. So after you've used infrastructure as code everywhere, right, scan it with checkoff, right? So this is our open source IAC vulnerability scanner. Some of you might be using this already. And I see there's a few lines in the chat, but I'll grab a few questions once I reach the end of the presentation here. So we acquired Bridgecrew about 2 years ago, and they developed Checkoff, and we intend to keep this plugin open source, right? So a lot of infrastructure as code languages, they're designed to get you up and running as quickly as possible with the fewest lines of code. And that means that they rely heavily on reasonable defaults, right? And these reasonable defaults, again, they usually don't make concessions to security, right? So never underestimate the amount of havoc that single misconfigured template can have on your security team, right? It can generate hundreds or thousands of runtime alerts. And by the time they find out who did that and chase it down, maybe they fix the template, maybe it gets redeployed and they come right back, right? And that generates that game of alert whack-a-mole, right? So like I mentioned, Checkoff runs in VS Code or as a standalone, right? It's a Python app or a container, and it sniffs out these errors just like a spell checker, right? It's totally free to use. And it not only detects these things in real time as you're writing them, but it also provides coaching on how to best resolve these issues. So if there's a quick fix, like flipping a true to a false, Checkoff will recommend it. And then for more complex issues, it'll give you a link to the documentation site so you can research it further. And you can also make skip comments, right? And that's kind of what you're seeing in the screenshot here. So if you really can't tackle an issue now, just skip it. And at least the security team knows that you've seen it, you've acknowledged it, and you're going to come back to it. So although it is completely free to use, I think you might need to make an account with Bridgecrew to get the results, but they're totally free. Customers can generate an API key for Checkoff, which enables custom policies in Prisma Cloud, and also software composition analysis, which is something that we'll touch on in a moment. So regardless of whether or not you're a customer of ours, grab Checkoff, throw into VS Code. It'll help you become an ISC security expert in no time at all. All right. So whenever we implement new and exciting technologies to solve our issues, like infrastructure as code everywhere, we inherit new and exciting problems, right? It's the cycle that keeps us all working. So with IAC managing all your deployments, it can sometimes be challenging to find the cloud resources you're looking for, right? Especially if everything in your console is named after random animals, right? So if you ever found yourself browsing around the console trying to find that resource you need to make a change to, auto tagging is a compelling solution for you, right? So in the same vein as Checkoff, we developed Your for precisely this use case, totally free and open source to use. It's an IAC auto tagger, right? So you can automatically tag your resource blocks with really any information that you want, like what repo it came from, who changed it last, what release it came with, and so on. You can customize those tags to be basically anything. And the whole thing is automated as a pre-commit check. So there's nothing for you to do except to commit your IAC code, wait 2 minutes for the GitHub action to kick off, and then pull it back down with your tags embedded. So for your friends in cybersecurity, right, this is a huge area that's basically impossible for them to solve, and it's called attribution. So if we're on the cyber side of the fence, we can try to guess what that EC2 instance might be doing based upon its name and location, but accurate tags are vital for determining who owns it, how important is it, like is it a prod deployment, is it dev, does it have sensitive data in it, and really who to call if something gets breached. Instant attribution like this is an absolute game changer, right? Particularly as most of our other security tools will let us group and report on assets by tag. So it lets us figure out like where are our hotspots, where are our deployment patterns, right? If I look at the tags, I don't have to call you guys, right, on the development side and ask, what is this instance? What is it connected to, right? That's an hour-long conversation that we can all just avoid. And then since we know what's potentially not needed anymore, it also helps us prune our unwanted assets. And that really reduces our overall exposure to the outside. So Your will do one other cool thing, right? It will also trace your assets, and that'll allow you to implement drift detection, right? Which leads us to our fourth tip. All right. So you're using ISC for everything, right? You've secured it all with Checkoff, you're tagging everything, but sometimes you still need to make manual changes, right? Perhaps due to unforeseen circumstances regarding performance. So we don't always want our Terraform jobs destroying live systems to implement these tweaks. So we do things the old-fashioned way, right? These manual changes, we call them drift, right? And these can cause issues down the line. Having a tool to manage it, like our very own Prisma Cloud, right, which is what you're seeing here, it's important, right? You need to have that visibility from where it came from in the repo, right, using that Your trace, and then spot it throughout the rest of its life cycle, right? So it should not only be able to tell you where it came from, what it's doing, but also guide you through remediating it, right? Either by pulling that running asset back to its template state, or by capturing those changes, right? Maybe they're necessary. Maybe the template wasn't right. This tool can then generate a pull request for you, right? So again, working in the tools that developers and DevOps ought to be working in, instead of booking more Teams meetings to talk about that drifting S3 bucket hiding out there, right? So for the friends in security, right, Drift presents a compelling opportunity. So instead of needing to, again, continuously audit everything that's running, we can just look for things that have been manually changed, right? It's a lot like installing that motion sensor in your home. It doesn't care where your furniture is, only if someone has broken in and they're moving around. So then the security team can basically safely assume, right, even if you have 10,000 assets deployed out there, right, across 100 deployments globally, we only need to look at the things that have changed. And if there's supporting documentation, like a Slack conversation or a Jira ticket indicating that's happened, then we're good. But if it's unexpected, we know exactly that maybe something's been compromised, right? Maybe your credentials are out there or someone's kicked a door down somewhere and they should respond accordingly. All right, so next tip here, right? So like we mentioned earlier, your applications and their dependencies, they will never be completely free from vulnerabilities, right? And if we develop our applications without any awareness of these vulnerabilities, we're either setting ourselves up for heartache as we inch closer to deployment, or we're handing a big bag of alerts to our friends in security, right? Neither is a good outcome. So if we use tools like Checkoff, right? And again, there are others out there, right? In conjunction with platforms like Prisma Cloud, you can perform SCA, right? And you get feedback on these packages directly within your IDE or your CI/CD process. So again, right, big benefits for security, right? And SCA tools, they're quite a bit different than SAST or DAST, right? SCA tools are just looking at all the ingredients, all the packages going in. They're not looking at the individual lines of code. So they tend to be quite a bit more concise in what those issues are, right? So vulnerabilities, number one, right? If you're using the same tool that the security team has visibility into, they know that vulnerabilities are being seen and again, acknowledged by the team that is most likely and most able to fix them. These tools should also highlight if vendor fixes are available and how much effort it will take to get there. So again, if you're just one maintenance release behind and there is a fix available, that's a no-brainer, right? It's an action that you could take immediately. But if there is no vendor fix, then we need to have a very different type of conversation. And then lastly, right, this is a big one that we hear, SCA can highlight vulnerabilities across all projects in the organization. And that's huge for triaging the most critical and exposed, right? So if you're a large org and you have 20 similar deployments out there, one person who's fixed the vulnerability in one project can easily be tapped on the shoulder and asked them to fix in the other projects and repositories out there, right? It's like benefiting at scale instead of keeping that knowledge tribal and isolated in smaller groups. Okay, so we're reaching the end of our list here, and we would be absolutely remiss if we didn't talk about secrets and how to manage those, right? Like we understand that this is a complex topic and that nobody is perfect. Sometimes you just need to hard code a few credentials somewhere and hope they don't land in a public GitHub repository, right? Maybe you have platforms which don't support key rotation very easily, or maybe you have integrations which only work with credentials that Dave built 18 months ago and he's been gone for a few weeks, right? You don't want to touch it, you want to break it. So I believe our friends here from CloudTruth will be speaking to you next about this, and I'm sure they have lots of great advice on how to manage your secrets holistically. And in the meantime, right, if you don't have a tool at your disposal, our colleagues again from Bridge Crew forked and maintain a project designed to help you sniff out secrets within all of your repos. So instead of taking the expected approach of alerting all the time on all the secrets everywhere you run it, this tool builds a baseline and then alerts you once new secrets are discovered. So we feel that this approach is quite a bit more useful overall, as it allows you to easily establish your stance on secrets and then slowly improve over time instead of expecting perfection today, which is completely unrealistic. If you want to take it a step further, you can run this as a pre-commit hook, and that's what you're seeing here in the screenshot. And you can block commits containing new secrets, and that's right for public repos. 100%, absolutely recommend doing that. It has a plugin based architecture, and it looks for more than just the usual AWS access keys. So very powerful tool, free to grab, just clone it, add it in, and away you go. All right, so finally, right, we have to end our list here with some CI/CD security. So this is the next frontier for the shift left movement, right? And it's such an important area that we acquired a company called Cybersecurity a few weeks ago to add their capabilities to our product and to really understand the breadth of this issue, right? Others would refer to it like in the DORA report, State of DevOps 2022, they refer to it as supply chain security. And that kind of touches on CI/CD and SCA holistically. Basically, a whole third of that report is about the importance of supply chain security this year. Right. And it's again, because your CI tools have hooks into almost all other key development systems. And that can span hundreds of repos and code projects. And if you have bad credential hygiene, those can be lifted and reused, and you wouldn't even know what's happening. And then beyond that, right, your build processes, they probably pull from a wide range of public projects, which are, again, are a potential vector for nasty things. This can lead to what we call dependency chain abuse, where a malicious actor can disguise a package, right, either by typo squatting on a package name, adding something in, promoting it somewhere, right? People will pull packages all the time, and if it meets their needs, they're going to run with it. And then lastly, right, as your CI pipelines get larger, there's a natural desire to streamline their performance for the sake of speed. And this is a great goal, but all pipelines need to have flow control mechanisms in there to ensure that the entire pipeline cannot be abused, right? This is a tough area because now we're directly talking about slowing down development for the sake of security. Think about your own pipelines and ask yourself how easy it would be for someone to push their own build all the way to right deployment and prod. If they can go all the way with just your GitHub credentials, expect the security team to come knocking right in the next few weeks or months here. So while there isn't a free tool recommendation you can start using right now to assess your pipelines, it might be a good time to start some early spring cleaning and come to terms with how they've been put together, right? Start taking the dust off and understanding how they've been built. All right. So before we clone some goats, let's get some questions. Let me take a look at the chat here. Latest is the most dangerous tag there is. Yes. People look at me like I'm crazy when I say that, but absolutely, right? You don't control it. You don't determine what's latest. So analyzing that image and looking at its behavior is absolutely essential. All right. Any other questions hiding out there? Ask me anything. Ask me anything about security or share some of your pains, some of the things that you've experienced here that I've mentioned. Oh,
when
Andre,
ChatGPT is going to start doing security reviews?
Depends how much you want to give ChatGPT about your environment.
I do have a question. You said IAC is declarative, correct?
Yes.
Do you consider a language like TypeScript declarative?
We like TypeScript, right? Like we're less leaning towards code security specifically. Like we're taking more of a bring whatever language you like, and we'll try to prevent bad things from happening to it. Sure. But yes, we like TypeScript.
The way I see IAC is going, like I had my fair share of HCL. Okay, a bit of background myself. I've been doing Java for 25 years. I have tons of white hair on my face, head. For those who come from the Java world or Python world, you write something like HCL, you just want to jump out the window right away. So the way I see that migration of IAC, it's not going declarative. It's going more OO. That's the way I see it. So for example, Terraform is coming with something called CDKTF. Preliminary is already out there. I saw that preliminary site. Great job, by the way. I don't know. It's just something I'm just wondering, should IAC be declarative? And for someone with tons of white hair on my face, I'm saying, I don't want to read any more HCL code.
Yeah, no, that's totally fair, right? Like we're seeing a lot of the tooling. Like one of my peers was showing me one of the Kubernetes plugins for Argo CI, and how its only goal is to ease some of that pain, right? Like Terraform's, when we say declarative, we usually mean like not as a language in how it's written, but in how it's telling your infrastructure to deploy itself. And when we talk to traditional infrastructure people, they think about things in imperative terms, right? Like I build the firewall, I log into the firewall, I build the policy on the firewall, right? You're building it all by hand. And then when you do that by hand, everything's, artisanal, right? It can be special because you built it, but then you make issues for yourself, right? If you switch to more declarative, right? And that's what we mean when we say ISC being declarative. You're telling it how to build itself, and it should take care of the rest, right? But to your point, it's not perfect, right? The languages aren't perfect, and they're open to interpretation. And we're seeing a lot of tooling come out that alleviates some of that pain.
Cool, thank you.
No, thanks for the comment. That's great. Any tool recommended from Niraj for Git pre-commit? Yeah, like a few that I mentioned here. So checkoff, you can run as a pre-commit hook, and that'll do the scanning, right? So if you want to block, right? So it'll do triage. It'll tell you if you're committing something egregious, like maybe you've included a secret, or maybe you have a publicly open exposed S3 bucket. You can block that commit entirely using the hook. As well as right? That auto tagging tool runs best as a pre-commit hook, because what it will do is regenerate all the tags on a fresh commit, as well as the traces. So the traces are just a UUID, right? Globally unique. So it just carries that trace through to deployment. So it's best if you regenerate them as a hook every time you're deploying.
Thank you.
Awesome. Okay, let's clone some goats.
Any other questions? I've got one more question. It's a little bit loaded, but what metrics would you use for security? And yes, we often ask, okay, what metrics do you have? Oh, we are not hacked. Well, that's the sort of lagging indicator. We don't want to be hacked. Is there any specific metrics that you recommend that should be watched to keep up proactively making sure that the code is actually working and is secure?
Yeah, no, that's a great question. From what we've seen, right, there really are no bad metrics. Like if you want to count vulnerabilities or count number of code reviews or count the number of rejected commits, right, based upon quality, or count the errors that your SaaS tool is giving you, that's fine. We usually say that keeping it relevant is the hardest part, right? Like how do you tie and how do you map one line of code that someone wrote that might be sitting in a feature branch a few releases back? How do you account for how that goes live, right? All the way through to where it could potentially cause a problem, right? And having an understanding of code all the way to cloud is the most important, and it is usually the most lacking, right? So usually we see as organizations get bigger, they'll have a security team, right? They'll have a DevOps team, and then they'll slowly start to talk to each other. And then eventually they'll say, oh, SRE, right? These guys know how everything is supposed to work. We're going to bring an SRE person into the team. And suddenly right now we have this happy little DevSecOps family, but it's really hard, right? Because the SRE people, they're born, right? They're made, right? You can't just turn someone into SRE. They need to know where all of the bodies are buried. And that knowledge brings out the relevance, right? So if you're counting vulnerabilities in your base images, for example, you need people with actual knowledge of the application to tell you that these matter.
All right, thank you.
Yeah, for sure. Just reading the chat. So thank you, Kevin. And there's some fun comments in there. All right. So hey, if you want to have some fun, right? So we like goats, right? So these are vulnerable by design repositories that we make some are out there. They're really designed to show you how things can be done in an insecure manner. So the TerraGoat is a good one, right? This shows you across all the different cloud providers how Terraform can be written in an insecure manner. So if you have checkoff, clone TerraGoat, take a look, right? And same with the supply goat. So this is all about supply chain and how you can inherit packages that you didn't even know existed by kicking off your build jobs. We have the CI/CD goat as well, which is a self-explanatory, right? These are from their friends at Cider who we acquired. This is actually delivered as a capture the flag via Docker Compose. It's a lot of fun. It's a little heavy, but you get hints along the way, and you can really see how far the whole CI/CD rabbit hole goes. And then lastly, we have the Kubernetes Goat, right? So this is more runtime focused, not one of ours, right? We have no affiliation to them, but everyone's slowly moving towards Kubernetes. So if you want to see what it looks like, give it a whirl. And then last slide, and then I hand it back. Bridge crew workshops. So if you do want a more guided approach through checkoff and IAC security, right? Not just Terraform, we do CloudFormation. So if you want to play with the pre-commit hooks and everything else, check out these workshops, right? bridgecrew.awsworkshop.io. That's it. That's my content. So thanks so much, everyone. It's a pleasure chatting with you this evening.
Thank you so much, Matthew. That session definitely resonated with me, and as I see, it did resonate with quite a few of our commenters as well. Finally, awesome. Some people are recognizing the pain on the other side of the aisle, right? Otherwise, it's always like, I find that a lot of people are always just vilifying our friends on the other side. Awesome. I see Andre has his hand raised.
Just clapping,
no,
I think.
That was clapping.
I appreciate it. Thank you. And thank you, Martin.
All right. And now it's time for our second session. I have been looking forward to this session for a really long time. Having spent most of my career in release management, there's very few other people I can think of who care about configuration management than I do. But it's definitely these two gentlemen. Both these gentlemen, Greg Arnott and Matt Conway, are co-founders of this organization called CloudTruth, and they're going to talk to us about configuration management today and how to handle this hidden tax when it comes to the vast configuration sprawl. So without much further ado, I'll hand it over to these two gentlemen to teach us about this. Thank you, Greg and Matt.
Thanks, everyone. We're delighted to be here this evening. We're located in Boston, Massachusetts, so about 3,000 miles, I think, from most of the folks here, orientated on the West Coast. Let me start sharing my screen. If someone just could confirm that it's coming through okay.
Looks good.
Okay, awesome. Terrific. So I'm Greg Arnott. I'm one of the co-founders of CloudTruth. I'm also joined here by my colleague, Matt Conway, who is our company founder and CTO. And tonight we want to talk about sort of new ideas and solutions for configuration management, take a couple different looks at configuration management from a holistic point of view. This is a perfect companion presentation to Matthew's discussion about security and then touch upon secrets. So we're going to take the conversation in a different direction to configuration management, which does bring in secrets. It's a big component of configuration management, and talk about security, reliability, and uptime, and the important role that config management does play there. So we're excited to dive into this, very important topic. As a backdrop to this discussion, I'd like to offer this perspective and the foundational thinking for our project. And I should mention, so Matt and I are the co-founders of CloudTruth. Our project, a shameless plug here, we're about promoting good configuration management best practices with some opinionated points of view about how best to think about managing config. So I'll be referencing some of our ideas there, but really this is more of a discussion around the aspect of configuration management that we learned about after interviewing 1,000 DevOps leaders as part of our thesis for how can we help reinvent configuration management and infrastructure as code for the new era. And it's because configuration management affects reliability, security, and cost control, especially when you're in a public cloud environment. So our agenda tonight is going to cover the 5 common sources of misconfigurations, configuration sprawl's impact on deployment velocity and reliability, and 7 new ideas that we're working on about better ways to manage configuration across all your environments, projects, and teams. So let's dive into this concept of the hidden config tax that's slowing down your deployment velocity. First, I want to kind of shine a light on this problem and take a look at it from a couple different perspectives. This is some recent kind of 48-point headlines in the news from a text perspective. Every time there's a breach, it gets talked about and the RCAs are revealed. So even organizations as sophisticated as Google and Facebook suffer the occasional outage caused by a misconfiguration. Just in the past year, Facebook has suffered a 6-hour outage that affected 3.5 billion users. So the ripple effect is tremendous here. And we've examined countless public RCAs that are typically made available after a breach. And we found too many examples to the effect of a configuration was incorrectly applied to a larger number of services than intended. And then the ripple effect of that unintended rollout of config that shouldn't have gone where it went is a common problem that we see teams struggling with. So that's an area that we think is really important to highlight, this idea that reliability suffers when you're not thinking about config in the right way. The other area where config becomes important is around protecting data. A recent report from McAfee found that 99% of misconfigurations are missed because of poor internal controls and tooling. So what's at stake is revenue loss, reputation harm, legal exposure. And these are areas that we can all do better at to help our respective organizations that we're affiliated with preserve their brand and so forth. And speaking of preserving brand, Matthew mentioned this earlier around the Circle CI breach and the LastPass breach. While we don't yet know what the RCAs are and whether any type of misconfigurations were part of the root cause, what we do know is that this became a huge headache from all the customers of those brands, which had then to go and quickly rotate all their secrets. And rotating secrets quickly across a massive deployment that might expand multiple geographic regions and time zones and teams and environments is a hair on fire moment. And so what we're going to talk about a bit is ways to think about making that easier when that does happen and less painful, specifically around secrets rotation. This is what we think of as the current state of affairs as it relates to config sprawl across 3 important dimensions: the number of environments that you're deploying to, the number of projects, your apps and your services that you're deploying to those environments, and the number of teams that actually have to touch those deployments or involved in actually writing the code that's being deployed to all those environments. And on the left represents the fact that today there are multiple sources of configuration data that are spread across your organization, from Git repos that contain JSON and YAML files as plain text config, or using something like SOPs or external secrets to embed secrets inside of Git repos, or dedicated secret managers like Vault or AWS Secrets Manager, or Azure Key Vault, GCP Secret Manager, or any other number of brands that are just focused on secrets, as well as state files for like infrastructure as code contains config data. So there's lots of sources where your config data lives today. And what's missing is kind of having visibility into all that, and then effectively transforming it so that data can be consumed by infrastructure as code tools like Terraform, or Kubernetes, or container management systems like Kubernetes, or Docker Compose Swarm, as well as your CI/CD tools, and your applications need a source of configuration as well. So misconfigurations are the leading contributing factor to outages and security incidences. And I mentioned the survey we did of 1,000 DevOps leaders over the past 18 months, and 75% of unplanned downtime was attributed to a misconfiguration, as well as security incidences. So it's really an important factor that we all deal with and suffer with, every day, daily basis, and it becomes this kind of hidden tax and grind on team productivity. And that's sort of one of the reasons that this project does exist, is to help make that easier. You've probably seen this holy grail virtuous cycle that we're all trying to implement some type of version within our own environment. I mean, this is sort of like the swan floating across the lake. It looks very serene above water, but below the water, those little feet are paddling furiously to keep that animal moving. So with this kind of thinking is that this is what we want to implement, this virtuous cycle of going from build, deploy, maintain, build, deploy, maintain. But the reality is messy. And doing anything well in the cloud ties back to configuration management. So config touches everything related to security, reliability, cost management, and all our collective tooling that we're using to manage all these different phases of the DevOps virtuous cycle has config behind it as well. So this is a multi-dimensional problem that we're uncovering. And it's really important that we think about the best ways to properly achieve uptime and security and cost control goals by looking at config from a different perspective. So I kind of wanted to dive in a bit around where we see this hidden friction tax manifesting within the organizations that we have visibility into. So config sprawl's impact is across sort of the two functional areas. There's the application dev teams that typically don't get involved in things like infrastructure and deployments, at least in the current way that where teams are structured these days. And then we have the sort of DevSecOps teams or platform engineering teams that are the groups that take that application code and get it into the production environment or roll it out to staging environments for testing and so forth. And where we find config sprawl friction happening is at both sides. So on the application team side, we're managing multiple permutations of build environment configs so that app developers can have an environment that represents where they're going to develop and write code that represents as close to the production world so that you get a better outcome faster. Or finding config information is a sore point for application developers because that's typically managed by the DevSecOps teams. And as teams are trying to work more in parallel and faster, having to break work strides and get information about things that are obtuse is challenging. And it's also increasing the mean time to recovery in terms of config sprawl's impact on recovering from an outage. From the DevSecOps team's perspective, we're finding toil exists around managing deploy tool change, rotating secrets, compliance reporting and auditing, tracking changes, sort of the nuts and bolts, sort of the under the waterline aspect of configuration management that typically the app dev team doesn't see because they're being abstracted away from this. So let's dive into the details in our research findings. So sort of the second part of our presentation, I wanted to highlight the challenges that we see teams are facing. I want to talk about the results of our interview of 1,000 DevSecOps leaders, where we gather their thoughts and experiences about the role configuration management plays in the build, deploy, and runtime pipelines. So we found that there's 5 common patterns here. I'm going to take a very quick dive through each of these and then link it into some new thinking that we're working on related to a better way forward. So they are duplicates, incomplete config, linked config, clone config, and bad values. So duplicate config. This is most appropriate for managing secrets and rears its head when it's time to rotate a password. Without a centralized view, it's easy to miss getting the new password pushed out to all the places where it's needed. And this is why it's such a hassle to rotate secrets, but it's so important today that all teams have at their disposal a ready, rapid rotation capability to deal with things like LastPass breaches or Circle CI or whatever happens that we just don't know about. And a way to think about implementing a way of avoiding duplicates is to use a dry approach to configuration management. And dry is an acronym for don't repeat yourself. And it's the opposite of wet, write everything twice. And when your config is wet, then you're going to be chasing changes across repos and playing whack-a-mole, updating that same parameter secret value in multiple places every time there's a need for a rotation. So we want to show and talk about ways to avoid duplicates as we move through this presentation. The next area of misconfiguration is incomplete values. And this problem usually manifests when trying to promote new features from lower level environments to production. We see this when dev teams are working in parallel alongside of a centralized DevOps group, which is responsible for orchestrating the deployments. And the action of adding a new application level config setting is often an area that causes extra churn and slows down deployment velocity. So our survey found that many teams are unnecessarily paying this hidden friction tax without a better way of automating the declaration of new config settings at the application development level where those decisions are being made, and how the DevSecOps team is aware of those new settings and doesn't get involved in endless wasteful time cycles trying to figure out why a deploy is not working correctly. Third area that we wanted to talk about is configuration that's considered linked. And what this means is an example of, say, where a DevOps team is going to scale up the number of containers, but forgets to scale up the number of database instances to handle the increased load that all those new containers are going to put on the database. So this concept of thinking about configuration values that are linked together is a way of managing config sprawl and avoiding unpleasant surprises. So forgetting to consider that parameters are linked will cause stability issues. And a way to avoid this is to think about some new ideas around a metadata layer that wraps around all your config, and an expert system that's kind of looking from the top down and understands the linkages between values and can either make smart recommendations or automatically keep two linked values consistent with each other, so you don't get this situation where you get an uneven balanced system where you have more processing containers pounding on a small database because that database didn't get sized up correctly when the containers were added to, or when the nodes were added to the containers. Another area we see teams dealing with configuration or misconfigurations is around cloned values. So this is common when, say, you're a fast-growing team and you're deployed mainly in one region, whatever cloud it is, but you need to move your software stack into another region. So a common example for kind of a North America view is you're in North America and now you need to deploy into a EU region. And there's going to be different config settings responsible for the EU version of your software and the North America version of your software. GDPR is an example where you have to have different config settings, either app level or an infrastructure level. So the concept of clone config is you need a way to be able to manage in a hierarchical fashion how the config is deployed. And the EU version gets a slightly different value than the North America version, but there's only really one declaration of that config variable. And you have replaceable values based on project and environment. So you have one place to go to think about your config changes. And that's kind of adopting that dry approach. And finally, the most common area of misconfiguration is what we call bad data or bad values. And we see this scenario common when config is mostly stored in JSON or YAML and text files within repos. So when you're making changes, you're using your editor and there's no type checking or validation on those types of changes. And that's where these types of misconfigurations can creep in. We've heard examples within the customers that we talk to. For example, a junior DevOps person made a typo in a cluster node configuration value, and the intent was to spin up a 3-node cluster for doing some testing, but mistakenly set the value to 33. And the cluster ran for 30 days, and then there was a quite expensive bill at the end of that. There's a whole sort of separate discussion on cost control and the ways that we can mitigate those types of things, but we're trying to avoid even getting into the situation where you have to rely upon your cost control analyzer to send up the red flag or the red flare that there's something here that shouldn't be running because it's consuming lots of CPU cycles and running up the bill. So the best way to avoid getting bad values into your configuration is to think about the concepts of type checking, rules and ranging on validation of values, linting on config data. And we'll talk about that as one of our ideas around the way forward. So that's a review of the five types of misconfigs that we see teams most struggling with. And so I wanted to take the conversation now and talk about some new thinking that Matt Conway and myself have been putting together related to concepts around approaches to managing config that should make our life easier. So we're introducing this idea of 7-factor config. And it's a set of principles that describes a way of managing secrets, parameters, and templates that, when followed, enables teams to reliably deploy, quickly scale, and reduce unplanned downtime and security incidences. So I want to briefly go through each of our 7 factors and talk about ways that we see teams moving in this direction, and then some ideas and some product concepts that embody these 7 factors. So our 7 factors are: keep your config dry, decoupled, abstracted, centralized, obvious, secure, and versioned. And all these principles are principles that we use in other aspects of our SDLC, software development lifecycle. But we're thinking about a special approach to the way that configuration data is managed, irregardless of which tools you're using. So if you're using an IAC tool like Terraform or Pulumi or CloudFormation or Bicep, it doesn't matter. These principles apply to IAC in general. The same thing with Kubernetes config or microservices config or plain Jane EC2 based instance type of config. So we're going to sort of think about this from a holistic point of view, but there's very practical applications of each of these within very specific use cases like configuring a CI/CD pipeline managing input variables to Terraform, managing your config maps and secrets for Kubernetes, passing in secret values into a Jenkins run or GitHub Actions or Argo CD. So don't repeat yourself, dry. This is probably our number one in terms of where we'd like to see teams put some critical thinking in and make steps towards a dry approach to config. Because if you're doing a dry approach, there's going to be some dependencies that are required to implement this that are all going to work in the right direction for you. And so what this means is keeping your config variable key names declared once, and then a flexible variable values as a point of insertion across your build, deploy, and runtime phases. So the benefit is it helps solve getting updates into critical secrets or parameters spread across your environment more efficiently. And it keeps related changes in sync. Example would be sort of your port numbers on your server side and your application, your client side. That's a way of thinking about, keeping your config dry. Decoupled. This is where we think about the concept of externalizing config from source code. You don't want any hard-coded config. And this is a pretty common pattern that we see most teams are very well suited for to declare victory, but there's always room to, I think, improve in this area. The concepts behind this are basically around separating code changes from configuration changes. And then it allows you to isolate the root causes of your code changes from your config changes and to be able to frequently update these changes as needed, decoupled from your code releases. Abstracted is another concept, and it's related to decoupled, but it's really about separating how your code and your configuration interact. And so think about this idea of separating the specific values like your log level from how one fetches that log level value. And the benefits are numerous in terms of the ability to create a configuration interface separate from its implementation. And it also is kind of on a path towards one of our other 7 factors, which is helping you make things obvious. And that's a key component that we think is going to be important. Centralized speaks to the problem set that we're solving with CloudTruth. And it's this idea of being able to get a consolidated federated view across all your config data from a single perspective, but still allow that data to live where it is right now. So not having to make big wholesale changes to get the benefit of that. Obvious is also very important in terms of it's a way of thinking about organizing config that makes it both easier to understand by people and systems. And this promotes the idea of onboarding folks onto your team faster when your config is obvious and organized, troubleshooting changes, identifying data quickly when you're in a triage mode. Countless times we've heard of this. We've heard this expressed to us from our customer interactions. How do I share my config patterns across different teams, across different schemas, another CLI to learn? This concept promotes the idea of simplifying and using a centralization approach, but still being able to support a decentralized consumption of the config. So it's the concept of being able to change or decouple the management of configuration data from how it's consumed. We often think of config as a big component of secrets management. And so our philosophy is, secrets are configuration, and configuration needs to be securely managed. And so apply a very strong role-based access control layer and an independent tamper-proof audit trail to your secrets and configuration management. We're storing so much data here that just has to be kept, very confidential, whether it's third-party API keys or production database passwords. And we're a big proponent of taking this late binding approach to the management of config. So this idea that where you need to inject a secret into a process, you want to do that as late as possible. So there's no likelihood that that secret could leak into a log file or kind of be stashed in an environment variable for some long-running instance, and that's a vulnerability attack vector. So late binding approach to injecting secrets right where they're needed in the build process, the deploy process, or for runtime apps. And our final 7 factors is versioning config. So this is in essence that helps DevSecOps get a handle on tracking changes, showing that your auditors that you've got a change management system in place, the ability to quickly roll back changes if a change has caused a problem, having the concept of everything is versioned, sort of the way we version everything in Git. So a similar analogy to versioning all config in a way that makes sense and can be consumed, because right now when you have your config living in some Git repos and some parameter stores and some secret stores, you can't get one consolidated versioned view of all that data from that perspective of quick triage and compliance and audit reporting. So that's a quick overview of this concept of 7-factor config. We modeled it after the very popular Heroku's 12-app config principles. And the third principle in that manifesto is externalize your config. And that really became some of the core thinking about what spawned the launch of CloudTruth is when one thinks about externalizing config, what are all the important concerns? And we came up with 7 important concepts that we wanted to share with you tonight. So I want to look at some concepts to consider to spur some new ideas and thinking around better ways of managing config to avoid misconfigurations and eliminate that config sprawl tax. So we've talked about a dry approach to configuration management. Here's some concepts that we're pulling forward within CloudTruth that become different ways of getting your team united around a single record of truth that's an aggregation of all your existing single sources. Again, it's Git repos and other parameters and secret stores. So this hierarchical structure keeps your config dry and allows you to make changes in one place, and all those changes can be rippled throughout your system as needed. And then the concept of being able to do rollbacks and understand changes and so forth is all kind of built into this type of approach. A centralized view of all your data is also something that we think is very important. And this is a way to get a synchronized cross-cutting view of all configuration settings, regardless of where they live. And with strong RBAC layered across this, you can expose this interface to everyone so they have self-service access to their parameters and secrets, whether it's from the build environments, the deploy, the runtime needs. So you can lock down production level config and secrets really tight, but keep dev and staging more open and self-service so that teams can operate, more quickly in parallel without having to be a bottleneck for the platform engineering group that's typically managing all this. Another area that we think is really important to highlight is the need for system-wide ability to track changes, see history of what's changing over time. This also aids in compliance reporting and DevSecOps needs for rolling up into a SIEM, all aspects of, I think, for the security posture, and especially when you think about secrets, that's important for your security posture. And just to be able to answer these fundamental questions like, what's different between staging and production? Why are we having an issue right now? It's often a config setting. So it helps you identify and diagnose configuration differences. And then the history of change of configuration values is important to help you answer that question, especially for production. What just changed? Why are we having an issue? It's often a setting that may have gotten into the system that shouldn't have been pushed out. And having that X-ray vision sort of immediately available to you can highlight that without having to log into countless interfaces to find and track down the potential change. And finally, the idea that configuration management needs to get smarter and have built-in systems that offer type checking, the ability to enforce rules and ranges on configuration values. It allows, say, the platform team or the DevOps team to set up the guardrails for config and then let other teams make self-service changes within those guardrails. So you can kind of promote the best practices of good hygiene, but also you're not going to be a bottleneck to letting all the teams running in parallel operate at their pace. So that's it. Really appreciate everyone's attendance and interest in our project, and we'd love to have some questions about what we're working on. Matt's here as well to answer questions as sort of a deeper dive, and would love any engagement and any ideas that come to mind after hearing about this topic.
Thank you very much, Greg. So do you have questions?
Any misconfiguration war stories anybody wants to share or commiserate? Maybe too many. Do our 7 factors make sense? Any contrary views?
Definitely made sense to me, and I'm just saying that if CloudTruth was around like 10 years ago, I could have saved a lot of time in my 20s doing other things.
Yeah, well, now we're trying to help everyone in their 40s, perhaps, and do more things.
If I had $1 for every time my supervisor wanted me to maintain configurations in a spreadsheet, I'd be a very rich man.
Yeah, and that is state of the art, is spreadsheet-based configuration management databases, or CMDBs.
Not so much anymore, thank goodness.
Yes.
So your tool, does it integrate with any other tools, secret management and encryption tools?
It does. It integrates with the common secret managers. So we become a federator of secrets in that case. So we can bridge across, whether it's Vault or AWS Parameter Store or Secret Manager or Azure Key Vault or whatever customers have. That's one of the core value props, is that federated approach.
Thank you.
Sure.
Greg, this is Neeraj. One quick question. We have something similar for the OpenStack as well. If anybody is working with OpenStack for a private cloud.
I'm sorry, did you say, do we have something or you have something?
No, do you have something that's similar to, because in the presentation I saw most of the public cloud names, but
Yes.
for the private cloud.
Yeah, we do. We have OpenStack and OpenShift of integrations as well.
And I assume there is a contact details as well if you want to get a little bit more details about those.
Absolutely. Yes.
Okay.
Well, thanks, everyone. Really appreciate your interest in what we're working on. And if you'd like to learn more, we can you can check out cloudtruth.com, and my email is greg@cloudtruth.com. So pretty simple.
Thank you very much. Okay,
Pretty cool.
If there is no more questions, then we can close the event in such a case. So thank you very much, Matthew, Matt, and Greg. And thank you, Ilse, Shai, and Willie, for organizing this event. Thank you, everyone who is participating today. And again, we are always looking for great speakers. If you want to present your case, your interest, your organization, please reach out to us, and we'll schedule you. So thank you very much again, and have a great evening.
Thanks, everyone.
Thanks, everyone.
Thank you.
Good
Bye-bye.
evening.
Bye.
Awesome. Great stuff.